I recently bought this small automotive auxiliary heater that's designed to plug into your power port, previously known as your cigarette lighter power. The reason being, my winter beater, I think it's developed a leaking heater core, and it's a really big job, and I thought, well, maybe I can bypass the heater core and then get by with something like this for a period of time for a defroster substitute. So I acquired this, and I'm going to show something with this. I thought I'd check it out before I actually pressed it into service. It's supposed to be rated at 150 watts. So if you have 13, 14 volt power, 150 watts on that, you'd expect, so if it was 10, let's say 10 amps at 14 volts, that'd be 140 watts. So it should pull a little bit north of 11 amps to get your 150 watts. So what I have here is I got this trip light, basically a 40-50 amp power supply that puts out 13.8 volt automotive voltage. So and I have that plugged in here over to here. So we're going to check out the current consumption and a few other things with it to see what's up with this. So first thing is, let's just turn this power supply on. It has a little bit of a thump. And we'll measure the current with this fluke clamp-on meter, which is pretty much overkill for this. If this pulls more than 10 amps, I don't have a DMM around here that's going to measure 10 or more amps without risk of blowing the fuse in the meter. So we'll use our Agilent meter here and turn this on and make sure the zero offset is tweaked here. These are 1 millivolt per amp, so at low currents like 10 amps it's not going to have a whole lot of resolution, but we'll see what we get. Alright, let's clamp that around there, and there's a switch on the back. One position is fan only and the other one is fan and heat. So which one have we got here? I think fan and heat is number 2. Alright. Okay. A little bit of warm air coming out of there. And we have 8.8 amps here. 9 amps, 9.1 amps. So less current than one would expect if it's actually 150 watts. So there could be some voltage drop. So I'm going to take, untangle these wires and measure what the voltage is here at the adapter plug. And what do we have there? We've got 12 point something, maybe a poor connection here. About 12.9. What is it up here? I should do this. I should have a tripod to do this. I can get this somehow. Well, I don't know if I'm going to be able to get that without a tripod. And we got the power more over there. We've got 13.5 or close to 14.5. So there's some drop in my leads going from the power supply leads to these leads over to here. I see we're at 9.5 amps. We do have warm air here. Good. Ooh. But what we do notice, man, this cord is hotter than one would expect. I mean, really, this shouldn't be warm at all. This cord shouldn't be. So I'll confess that I previously checked this out before making the video, so I kind of staged this a little bit. But this time I do have thermal camera here, which I did not have before. I had noticed the cord was warm. I'll wait for this to start up. Okay. Alright. So what do we see here on this cord? And it's like 50C. The cord is 50C, so the cold background is, you know, 20-25C room temperature. So this is definitely got some temporize to it that really shouldn't be there. Let's check that out. Alright, so the gator clip obviously is warm. I'm not surprised at that. Gator clips are warm. However, even the high temp of those, you know, isn't that hot, you know. Let's look at that. You know, the max there is what is it? I mean, it's, you know, not really warm per se compared to this. I mean, this thing's auto ranging. So now we're up to almost 60C here. And what's the temperature at the vent coming out? Yeah, it's like 100C or something like that. I'm looking at the screen and I'm not looking at my camera screen, so that's why I deviate a little bit. But yeah, our outlet temperature is around 100C, a little over 100C. You know, you'd expect that to get sort of hot, but you don't expect the cord here to be so hot. I mean, now we're up to 62C. That's kind of disconcerting. Wow, yeah, that's pretty darn warm. I don't like it. Oofta. Seems dangerous to me. I mean, even in the winter time. I mean, the fact that I got this, you know, wrapped up is making it worse, of course. But you wouldn't expect this to get hot. Alright, so what I'm going to do... That's nice. Some warm air coming out of there. I don't know if it'd be enough to defrost a windshield when it's like 0 degrees out like it is this morning. 0 degrees F, that is. But better than nothing. Let's check out this wire. I wonder if this is just completely undersized wire. Oofta. That is really hot. What do we got here? It's like pushing 70C at times, it looks like. Definitely hotter than it should be. Alright, we'll take a few things apart here and try to get an idea on what gauge of wire this is using. Alright, I took it apart. Just had 4 screws, came apart pretty easily. You wouldn't expect to be much in here, and there isn't. So, yeah, cord comes in here. There's a rocker switch, and we have a little looks like a squirrel cage blower fan. Nice little 12-volt fan here. And these 2 wires with fast on tabs connect up to the heating element, which is this little guy. So I tried, and that's why I have my calipers here, tried to measure what size this cord wire is, which is a little difficult to do. It seems like, and then comparing it to some known wire that I have laying around, as far as size that is, it seems like it's probably 16 gauge, which, you know, doesn't seem too terrible. But not you know, as we saw, it got a lot hotter than I'd want it to. 16 gauge, pulling, you know, around 9 amps or so. So I mean, it definitely seems this wire is undersized. So I'm going to take a look here quickly at an ampacity table to see what, you know, if we have something around 10 amps or hair more, you know, what would be the recommended wire size for that, you know, if 16 is too light. So I found this wire table, and I don't know if this is coming out too careful in the camera. So if we had 16 gauge wire here, which is a diameter of about 50 thou, and that's kind of what I measured with my calipers, so I'm thinking probably it's 16 gauge. So if you look over here, let's stay on the same column. So what they're telling you here is single core, according to what the description was, that's like a solid piece of wire. And then we got how many strands, if this is stranded wire, right? So just looking at this thing, it's not real coarse strand like this, but it's not super fine either. So I'm just going to guess, let's say it's in the 7 to 24 range. So if we go down here again, that says 7 amps, and we had 9-ish. So, but if it was a solid piece of wire, it's saying 15. So the more strands you have, it looks like the current is derated, you know, quite a bit actually, depending on how much stranded, you know, how many strands in the stranded bundle there are. So it kind of seems like, yeah, this 16 gauge, assuming that's true, is undersized, which we saw that because it shouldn't really be getting hot. I mean, you don't want your cords to be hot. That's just never a good thing. So I have some other wire, and I'm gonna try substituting, you know, that cord with something else a little heavier. You know, I think I have some 14. So if it's the same number of strands or similar, you know, okay, that says 10 amps. So all else being equal, it should run cooler. So we'll take a look at that. Alright, I'm going to start on taking this apart. I used the ohm meter, and I already moved the soldered wire from here. Just this one. So this conductor for the switch went to the outside lead of the adapter plug, which is this steel spring. So I want to make sure I get the polarity correct in case it matters. I did notice it looks like there's a little diode underneath the switch, and I don't know if that's to protect the fan motor, but I'll make sure I get the polarity wired the same way it was. And what I'm going to do, I have some other wire here. Bear with me. Let's see here. So I have this stuff, which is like a bonded red and black pair, and I believe this is the same gauge as what's in here, which is 16 gauge. And then I have this stuff, which is a little thicker, and it should be 14 gauge. So I'm going to try replacing the cord with this 14 gauge, and we'll see if this gets equally as warm as what the cord they had in here is. So I'm going to go work on swapping this out off camera, and we'll come back. So I got at least the inside ends of this cord swapped out. with this heavier 14 gauge wire. So got one end soldered here. I got a crimp here. This wire was soldered to the tip. I had to trim this plastic off. I didn't change this. This is a really thin wire, but it's not very long. We'll see what happens with that. So the next step is to hook that back up on here with the vent bezel, screw it back together, and I think before I put the power adapter end back on, I'll just power it up from the pigtail ends of the new wire first, just to make sure everything is working. And then we can put that together and see if the wire runs cooler. I expect there to be less voltage drop through the wire, so the heating element should get hotter. And that, I know part of me keeps thinking that they deliberately undersized the wire to take up some of the load, so that, you know, if I put a fatter wire in it, the heating element gets hotter than expected, and that's going to cause some kind of problems. We'll see. Okay, I screwed it back together, and I just stripped the ends of the new cord, and I hooked that up to the power supply here, and it's been running for a minute or two. Get some, you know, warm air coming out of here. Now we have about 10.5 amps instead of 9.1 before. So we gained an extra amp of current in this. I mean, the cord isn't rolled up like the original one was, but I mean, it's not, you know, obviously hot or warm like it was before. I guess I should roll it up like it was before to do an A versus B comparison. I mean, if you think about it, if I have one more amp of current, I guess we'd have to do some Ohm's law on this to see how many watts were probably going into the old cord versus the new cord that were lost there and not going into the, you know, to where it should be going, which is, you know, providing hot air to blow on your window. You know, it seems to me that it's probably more than a few watts are now going where they should. Alright, I'm going to, let's put the original end on this and then wrap up the cord like it was before to compare to what we saw on the start of the video. Okay, we got the replacement heavier gauge cord completely installed, and we wrapped it up like the original one was. Got the power port plug on. So we're going to repeat our earlier test and see how that compares. Alright, turn our supply on again. And turn the switch on in the back. And we're pulling. It started off it always starts a little lower current, then it seems to rise. So here we are back at over 10 amps, 10.2, where prior we had only about 9.1. Alright, get some nice warm air out of this. Let's see, how's our cord doing? Doesn't feel hot yet or anything. Alright, let's get the thermal camera here. Let that boot up. And we need to do this quickly. I see I got a low battery warning light coming on. Okay, what do we have? What do we have for this cord right now? So max temp on the cord is about 30°C right now. Remember, we had something north of 60°C before, which is why you could feel it being hot. So it's not, it's a little bit warmer than room temperature, but it's not like a lot warmer than room temperature. Let's look at this. Yeah, these clip leads will get hot. You know, there you got some like plated steel. You know, it's a contact point. Alright, and then I don't know if we can see this, if it's any hotter than before. Actually, it probably is. I think it was like 100 to 110°C. Now we got 130°C, which, or 140°C actually, I see occasionally. Yeah, so it's definitely getting more power to the intended load. Whether or not that proves to be a problem is another question. Checking the cord again. Yeah, we still have, you know, maybe about 30°C on the cord. So it's not, we don't have a hot cord anymore. And when I try this out in the vehicle, whoops, what are we looking at here? Got that 10.3 amps. Yeah, well, we end up trying this out in the vehicle, and we'll see, you know, maybe, I mean, given the, you know, whether or not this actually does any good for as a real defroster substitute remains to be seen. But it was just a thought to get me by on my winter beater until the weather slightly improves, where I can attack the bad heater core problem. Alright, I think that's going to end this video.